Good morning, everyone. So it's great to be here at .NET Fest. I'm really happy that they asked me to come and give a talk on a topic that I'm very passionate about. And it's been a great time so far. I've met some really good Ukrainian software developers. And in general, I think the .NET Fest guys have done a great job organizing this. So I'd just like us all to take a moment and give them a quick round of applause. I think it's a great conference you guys have got going here. I'm going to take a note out of Dino's book here, actually, and just get a quick selfie with everyone, if everyone doesn't mind. Ready? Right, hands in the air, everyone. Nice. Excellent. Cool. I feel a bit sorry for you guys today because you are going to get it quite hard about legacy code. It's quite a big track today. We've had Dino this morning talking about code smells. My talk is going to be around some useful techniques to deal with those code smells. And then later on in the day, we've got more legacy code with Dylan. So maybe if I, sorry, Windows. Need to make sure I click on there. There we go. Right, so who am I? I'm Nathan Johnstone. I'm the chief architect at a company called Omnia Retail based in Amsterdam. And what is it that we do? Well, Omnia is a SaaS offering, and it's around online pricing and marketing automation. We help our customers regain control of pricing of their assortments. This saves them time and helps them to get optimal growth. This is done through a number of services we offer, ranging from competitor price information, dynamic pricing based around a very large configurable rule set. We have price elasticity calculations, and then we also have dynamic marketing, which is around making sure that you're bidding on the right products on Facebook, Google Marketing, and other channels like that. Currently, we're in scale-up mode, which is pretty exciting. So we've switched from being a startup. We've thrown stuff out there. We've got a lot of really big customers that use our software, and we're making good revenues. So now it's time to switch to being a scale-up. And what a scale-up means is we have to have a very strong focus on site reliability engineering, making sure the quality of our distributed architecture is at an appropriate level, and also moving to the cloud. We're moving to Azure, and one of the technologies we aim to take advantage of in Azure is Microsoft Service Fabric. So that's some interesting things about us. What is today going to be about? Today is going to be a discussion around the difficulties of dealing with complex code. And the reality of it is that anytime you're dealing with a legacy code base, you're almost certainly going to have a complex code situation. So I love legacy systems. I think it's the mark of when you get to be a good senior developer that you start liking legacy code more than greenfields code. It always provides a really interesting challenge. The technique we're going to talk about is called the Mikado Method. And what it provides is a minimalistic process, so it's not very big on ceremony. There's only 4 steps. But what it helps you to do is it helps you to break down a big change into a bunch of prerequisite changes. And if those prerequisite changes are too big, it breaks those down into smaller prerequisite changes. And you end up with a dependency graph that you can work your way from the edges back to the center. But before we begin, I do need a bit of a warm-up. And I have to apologize. I'm just coming off the tail end of a cold, so if I sound a little bit strange, it's for 2 reasons. I do a bit of a warm-up because talking to a room full of people is always a bit nerve-wracking. I'm not really a natural sort of get up and talk to lots of people like Dylan and Dino are. But the other reason is that I have a different accent, which you might have noticed, apart from the cold. So moving to Europe, I found that I was a little bit hard to understand, and even talking to other English-speaking nations, they do tend to get a little bit mixed up. So I have some easy slides to help talk a little bit about myself, but it's mainly so you guys can dial in your ears and get used to my accent. If you haven't guessed, I'm from New Zealand. This is not an Australian flag, this is a New Zealand flag. It's in the Pacific. But if you don't know where that is, I don't blame you, because there's currently a worldwide conspiracy at large to remove New Zealand from maps all across the world. It's a real conspiracy. I've come across maps in Spain and Portugal where New Zealand has not been on it. And this is the World Health Organization. Do you see New Zealand there? No. It's got numerous other little islands. I don't even know the names of half of those little islands, but New Zealand's not on there. It's a conspiracy. But I'm happy to report that the hotel I'm staying at, just across the road, the Mercure, Kyiv is not part of that conspiracy, and hopefully in the Ukraine at large, because New Zealand is on that map. It's right there. They've got it the wrong way around, though, Because in reality, New Zealand's at the top of the world, right up there. So I grew up at the bottom of New Zealand, or the top of New Zealand, depending on which way you want to look at the globe, in a little place called Invercargill. And while it's not quite Antarctica, sometimes during winter it can sure feel like it. You've probably heard a lot of jokes about how many sheep we have in New Zealand. For the record, there are no hobbits, there are no dwarves, there are no elves in New Zealand. Let's just get that straight now. Maybe there might be one dwarf, if anyone knows that guy. We do have some amazing places in New Zealand, though. And if those fantasy creatures really existed, they probably would choose to live in New Zealand. But I'm a bit biased. So now that my job to Tourism New Zealand is done, let's move quickly on and talk a little bit about me. I've been a software developer for around 18 years now, since Y2K. This is a picture of my first computer. Depending on your age bracket, you may or may not have heard of Commodore or VIC-20 or Atari. Atari is not a games company, it was actually a computer company way back in the day. But this is a picture of my first computer that I got. And it was so advanced at the time, it came with a tape drive for loading my games. Now, I never had the chance to download a game off the radio, like what Dylan was talking about yesterday. But I got sick of those two games pretty quickly. So I went rummaging around with what my Commodore 16 came with, and in the back I found this basic programming manual. And I thought, aha, this looks interesting. So I sat down and I wrote my first computer program. And I'm sure some of you at this point in time are going to know what this computer program was. My first line of code was 10, print, Nathan rules. Next line of code was 20, go to 10. And after that I knew I was hooked. And the rules back in those days were you always had to leave a little bit of space in between your line numbering because you never know when you wanted to come in and insert some more code. So that was why it was generally 10, 20, 30. A little over 2 years ago, my wife and myself moved our family to Amsterdam. Well, not to Amsterdam, sorry, the Netherlands. We live in The Hague and I work in Amsterdam at the moment. And mainly that was just New Zealand is so far away from everything, we wanted the chance to come and experience Europe and see what there is to see. So, that's my little introduction over. Hopefully you've all had the chance to sort of dial in your ear now to my accent. So now we're going to do a little test. So I've just finished my washing and I'm ready to go hang it out on the line. So when I go hang my washing out on the line, I use pegs. So what picture do you have in your mind? If you have that picture in your mind, you might need to pay close attention as I talk for the rest of this presentation. Pegs, not pigs, those are pigs. I said pegs. Right, so let's start with the story of a code change. This is going to be something I'm sure that everyone's encountered that deals with legacy code. So it's a brief, generic sort of overview of a code change that should have been easy, and I've seen this countless times, and I've been in those changes myself countless times. Luckily, not really in the last 4 or 5 years, but before that, a lot of times. So what the problem was we had a product where we had to upload documents, and they were fairly sizable documents, 200, 300 megabytes, and you've got to remember this was 5, 6 years ago, I think, and New Zealand being at the top of the world, we don't really have good broadband, so things took a while. So one of the features we wanted to build in was that when an upload failed, instead of having to start again from the start of your 200 megabyte document, we wanted people to be able to resume their uploads. So I got the requirements, I had a look around the code, thought, no, this doesn't actually look that hard. I probably won't have to do too much analysis. I'll just get started on it. So I rolled up my sleeves, sat in front of my keyboard, and I started implementing the changes I would need to get this resumable upload feature working. Now, an interesting thing happened. As I started making changes to the legacy code base to bring this feature in, things started to break. I had to change a class over here, and then I had other things change. I had to go fix those things. And then I had a bunch of tests change. And I'll go a little bit of a tangent here. I mean, I love unit testing, but if you come talk to me in the expert corner afterwards, you'll see that unit testing isn't quite the unit testing that a lot of people do these days. So the problem I had with this particular solution was everyone had a unit test against a class. So every time I changed something to try and break this feature, I had thousands of tests fail. Well, not thousands, but hundreds anyway. So I went around in this really nice loop. And eventually, I got to the point where I still didn't have anything working. It was probably about 8 hours worth of coding and changing. And what did I do? Well, I did what any good developer would do. I thought, I can still fix this. Go home, have a sleep, let my subconscious work on it, get up in the morning, and come back in. But before I even realized it, it was 2 or 3 days down the track, and I wasn't actually making any progress at all to do with the feature. What I was actually in the middle of was a titanic struggle against the code base itself. I actually felt that I was fighting this epic battle against this organism that was doing everything it could to prevent me from making this change. So given the situation and the endless horde of demons that were coming out of the code, again, I did what any reasonable developer would do. And what do we do in these situations? That's right. We put our surgical gloves on, we look at the steaming pile of mess that our changes become, and we go, you know what, I can still fix it. I'm still going to keep going. So if you take this approach, can anyone guess what your Git commit history looks like after this? You know, you've spent a day or 2 days, and you've finally managed to get the holy trinity. You've got the code compiling, the tests passing, and now you're ready to make that commit. But you look at the 200 or 300 files you've changed, and you think, yeah, the rest of my team's probably not going to want to see a commit that's that big. And with our modern tools that we've got, like source control, source control's multi-platform, Git extension, etc., what do? We open up source control, and we look at those really tempting buttons that say stage lines or stage chunk. And then we go, you know what? I can make it look like I did this lots and lots of little commits. So then we go and start to stage hunks, and we start to stage lines. And we make our commits up. And sometimes they even make sense. Sometimes they don't. Now, I really pity the person who has to come along and do a git bisect on that git commit history. Because as you're staging hunks and staging lines, it still builds on your machine because you're not getting rid of all the future changes. You're building with the whole code base there. So your git commit history at that point just becomes like the aftermath of Battlefield. It's just littered with commits that either don't compile, or they compile but someone didn't update the tests, so they compile but they fail because the logic's not the same. It's a really rough place to be in. Good luck trying to do a git bisect on that. After all that pain and time, the final result was that we couldn't actually deploy it into production without a lot of intensive regression testing, just from the sheer amount of edges and boundaries and code changes that it impacted on. So I began to think to myself, surely there must be a better way to tackle this kind of change, which is almost every kind of change if you're paying attention. So a few years later, I stumbled across a really good book. It's the Mikado Method. Now at this point in time, the reason I put the book cover there is that I've discovered after many conversations with people, again, not with New Zealand people, with other people, every time I talk to someone about the Mikado Method, they Google it on their phone and they go, I can't find it. Where is it? I'm like, how did you spell it? Oh yeah, M-E-R-C-A-R-D-O. I'm like, no, I didn't say Mercado, I said Mikado. There's no R in there. So that's why I've started to put the title of the book in the slide. So it's the Mikado Method. There's also probably a pronunciation thing there, because I think Mikado is another way of pronouncing it, which is probably the correct Japanese way. So what is the Mikado Method then? Well, the easiest way I've found to describe it to people is to compare it to a room full of furniture. Compare it to shifting a piece of furniture in a room full of furniture. So in this situation here, this is my room. And I've got a dog that's like chewed the hell out of my couch. So I need to bring a new couch in and get rid of that one. So I could do it this way, which is how we approach software change generally. I could get a couple of strong mates in, we could all pick up the new couch, we could bring it over, we could try and kick the table out of the road there while we're still holding the couch, then we try and kick the other couch back, we put that couch down, and as you can see, that's just not how we shift furniture at all. The way that we normally shift furniture is we take a look at the room. If you really wanted to do it the Mikado way, we'd go pick up the couch, and then we go, oh, okay, I can't move this couch because the table's in the road. So put the couch down, then we go to pick up the table. We start picking up the table, and the fruit bowl wobbles, and we go, okay, we can't shift the table until we move the fruit bowl. So we put the table back down, then we pick up the fruit bowl of apples. We put that away safely to the side. We come back. Then we pick up the table. Now the table's easy to shift because we got rid of the fruit bowl. Move the table over to the side. Then we go pick up the couch again, and then we take one little step, and we start to trip over the rug. So we put the couch back down, and we go, okay, in the interests of safety and trip hazards, I better move the rug. So we roll the rug up, we move that away to the side, then we go back and we pick up the couch, which is now really easy to move. Imagine how hard it would have been to move without moving all that stuff. So we take the couch out, we put the new couch back in, and then we go back in reverse, and we put everything back. And that really complicated change of putting a new couch in suddenly became a bunch of easy steps. So I think we get a general feel for what the high-level overview is now of the Mikado method. I mean, it's basically divide and conquer. That's all it is. Taking a larger set of changes and breaking them down into smaller, more manageable sets of changes. But why are larger changes something to be avoided? So the main problem with larger changes in complex systems is it becomes really easy to get caught up in a tangle of code dependencies. Like I was mentioning in that war story, one code change means that 3 other things need to change, which means 9 other things need to change, and tests. And then you've got acceptance tests, which generally aren't even in your compilable solution. It might be another solution that runs your acceptance tests. So it can get very easy to get too many things in your head. So this is where the rule of cognitive limits comes in. So following that approach leads to generally big pull requests, things taking a long time, a git commit history of hell, like we mentioned before. But there's also a theory of cognitive limits, which is basically the fact that the average human in their working memory can hold 7 plus or minus 2. You might have heard of that magic number before, 7 plus or minus 2. It's actually the result of some research, and there's an excellent paper by a guy, George Miller, from 1956, that goes into the theory of cognitive limits. What does all this have to do with the Mikado method? Well, let's move forward and find out. So the first step of the Mikado method is to set a goal. So in the previous furniture shifting one, our goal was to put a new couch into the room. So in code, your Mikado goal can be as big or as small as you want. It could be something like moving something that needs to be moving. Say you've got a solution that's got multiple responsibilities and you want to take part of it out and you want to put it into a new microservice or appropriately sized domain-specific service. That could be a Mikado goal. Or it could be something as simple as moving some code into a common library or being dry and moving some duplicate code into a common place. So once we have the goal for the Mikado method decided, we visualize it. And this becomes the basis for our next experiment. The key thing to remember is that you always start your goal with your code compiling and your tests passing. So, experiments. So in science, an experiment is a procedure for establishing if a hypothesis is correct. If anyone's seen this picture before, it actually has another comment there beside it, but I couldn't really put that in the slides, so... An experiment is a procedure for establishing if a hypothesis is correct. And one of the things that comes out of an experiment is generally new insights and new discoveries. For the Mikado method, it means that we change code in order to achieve this. So when we change the code, we can see which parts of a system break and which parts fail. And this gives us our goals for our next experiments. The feedback we get from that shows us the prerequisites for the next code changes. So an example of a typical experiment might be something like there might be a class that's public and someone's made it public for various reasons, but really it's part of the internal API of your assembly. So you might decide to reduce that to internal. Then you'll find a bunch of things break. So you've got to come up with a solution for that. Another typical small example might be a class with too many responsibilities. So you want to extract the class from that. Generally, there'll be things that break when you do that. So those are some examples of some small goals. Once you've got your goal, you then draw it up. So this is the visualize step. And this is probably one of the most boring slides in my whole presentation because there's no real nice images for this. It's just got to show you a picture of what it looks like. So this is where we start to help our cognitive limits of the 7 plus or minus 2 by offloading stuff to external systems. And our Mikado graph is our external system. So things that we find out, all the complexities that bubble up as we change code and break things, we put them on the graph. And then our brain doesn't have to keep track of them. So the Mikado graph is just a DAG, or a directed acyclic graph, which means that everything points away from the goal because that's the way you're generally approaching it. You've got your goal and you explore outwards. So you point outwards. I normally prefer to visualize my Mikado graphs with electronic tools. When it's small, when I'm working by myself, or when I'm pair programming or working with someone else, we'll generally use something like MindMap or Draw.io because they're quite good for collaborating, and they do a good job of drawing a DAG. But for a long-lived Mikado graph that's tackling a really big problem, let's say it might be a 3 or 4 week refactoring, maybe you've got the whole team involved. The best place for those is actually on paper. Get the biggest sheet of paper you can find and put it next to your information radiator about your team. So your information radiator is something that comes out of lean terminology, but it's generally where you've got your Jira board, your Kanban board, and all the other things about your system, about your team. So stick it there. And as you update the nodes, and as you cross stuff off, and as you do experiments, it means that everyone can see what's happening, everyone can see where you're going. The next part is the bit that most people find the hardest to get used to. So you've just spent some time doing an experiment. You think you can almost get there, you think you're going to put those surgical gloves on and just keep going till you get it compiling. Don't. Mikado Method normally works best if you limit yourself to 15, 20 minutes. I find 30 minutes starts to get a bit long. And the general goal of software development is to be intentional. If you're banging out 1,000 words, you've got code change. If it takes you, if after 20 minutes you've got thousands of lines of code, my feeling is you're probably doing something wrong. I can type fast, but I'm lucky if I type more than 10 or 20 words and then I think again. My general development process is So I find that I don't have that much code to throw away at the end of 15 minutes, 20 minutes. But what I do have, the most important thing, is I have a whole lot of insights about the system. So that is the most important thing. There is no value in the code you've written. One of the things when I first started doing the Mikado method that I got tempted to do was I stashed my code, thinking it might be useful when I get back here. I've already done some work. I want to start back up from here again. I can definitely tell you with 4 years of experience now, that never works. By the time you get back to that node, if you think that you've got 10 other prerequisite changes before you can come back and make that change again, the system will be so different and you'll get a much better result if you just do it again. So the other reason we undo is what I mentioned at the start. We always want to start from a known good. An experiment is only valid if you start from a known state. And the known state has to be the system builds and your tests pass. So kill it with fire and then move on. So I'm going to run through a couple of the advantages now of the Mikado method. One of the advantages is you generally don't have any refactoring branches, because one of the ways that dev teams always approach oh my god, it's technical debt, we need to refactor it, everyone makes a branch for a start. And then you can have all the best intentions in the world of rebasing and keeping up to date with the other developers in your team, but someone's going to have pain. If it's a big refactoring and if your changes aren't going back with the team, or if you're pulling their changes in, they're working on a completely different view of the world. So you've got to keep their view and your view aligned because you're the one doing the refactoring branch. The advantage of the Mikado method is because it focuses on small changes and you always keep the code compiling and all the tests passing, there's no reason those changes can't go back to the main branch where all developers are, or even into production if you're doing continuous delivery and continuous integration. Another advantage is it genuinely is faster progress. Once you get good at it and you get used to just going git reset hard, killing it, you do make faster progress. I think it's like a mountain climber climbing up a mountain. They put those spikes in and they tie their rope on, and then you put your next spike in and you tie your rope on, and that's kind of like your Mikado graph. As you get to the edges and you find code that actually only takes you 10 minutes to change and everything works, the spike is the commit you just put in. Because the next experiment, when you go git reset hard, you're not going to lose that commit because you've already finished that part. So it's like a guy climbing up an ice mountain with the spikes. The next advantage I like is it's really hard as a software developer to get in the zone, because just doing anything these days, there's so many distractions. You've got your email, you've got pop-up messages, you've just got all these micro distractions that, the little dopamine receptors in your brain just love that stuff. They're like, bing, oh, there's something I can do. Bing, there's something I can do. So I generally turn my email off for big times of the day, and I close my Slack down as well. If anyone wants me, they can come to my desk or ring my phone if it's that important. But the main advantage is that once you're in the zone and you've got your Mikado graph and you've generally only got 10 or 15 minutes worth of stuff in your head, when your manager comes over and goes, hey, you're a software guy, can you help me with a problem? The printer doesn't work. Then at least, it's easy to get back in the zone because he's not just suddenly shattering 3 hours of complete concentration with his printer problem. This is something I'm big on, is intentional programming. Dino sort of touched on it during his code smells and that is code smells talk. So intentional programming is making sure every line of code you write, you understand why you're writing it, and you've got an end goal in mind. What happens when you get into that spiral of chasing broken code is you end up just slinging code in there to get things working because you want to get a commit in and you want to run some tests. So with the Mikado method keeping you focused on smaller chunks of code that build, pass all the tests, it really helps you to focus and be intentional. Collaborative refactoring, another good advantage of the Mikado method, it allows teams to collaborate really effectively on large code changes. You can share a Mikado graph. One of the interesting things is because it's a DAG or it's a graph, it means you can either concentrate on going depth first on any branch, or you can go breadth first, which is just try and find as many branches off the root node as possible. If you go breadth first, so you do an experiment, you find some things that change, you get reset hard, but then instead of tackling that new node you found, you go back and you try something different, something else that might break. You can quite often find a couple of parallel branches that aren't linked that multiple people can work on at once, which for big refactorings, when you really want to change the shape of a code base, that works really well. So, visibility for large changes, this comes back to something I mentioned before. One of the things that makes managers uncomfortable and anyone else that's in charge of a software development team is just not knowing what's going on. If you take a great big piece of paper and you draw a Mikado graph and you update that every day or every couple of hours with new discoveries, people get the sense that there's progress being made. So it's a really good way of visibly showing refactoring. And by the way, I should have mentioned this at the start actually. In general terminology, I use the word refactoring when you're making changes to a code base and you can prove you haven't changed any behavior. If you don't have unit tests, if you don't have tests covering anything, you're not refactoring. You're just changing stuff. So there's a big difference. I see a lot of people use refactoring when there's actually no way of proving that they haven't changed anything. Not really a good use of the word. And that's why managers hate it. When anyone says, I'm going to refactor the code, they've been burned too many times in the past by using the word wrong. It does lead to higher quality code. All of these little ways of attacking a complex change leads to higher quality code. It also gets you to the point where you can actually start doing CI and CD on big, large technical changes. Every couple of hours you're pushing through the latest pull request, which doesn't actually do anything yet because you're attacking it from the edge. But when you get to that final change, you've already solved all the problems that happen. So now it's time to do a bit of an example. The example is from Daniel and Ola. They've got a GitHub repo that you can all pull it down and have a try. There's two flavors of it, I think, Java and .NET, C#. So it's a really simple example, but it's good. It starts off with a successful software company called Gargantua, I think, but they've got an encryption algorithm. And like all successful companies, suddenly they're a victim of their own success and they've got another customer coming on board. So they've got lots of money coming in now because they've got this other customer coming. And they want the encryption algorithm, but they want a different version of it. To complicate matters, the UI for the software has had so much money invested in it, and it's so complex, probably because it's written in JavaScript. But they want the UI to be reused, so every new customer has to get the same UI. So the algorithm, however, that the other company's paid for cannot be shared. That is that company's. So the UI has to be shared between all new customers, but each customer's algorithm has to remain their own. Now, as with any code example, it's deliberately simplistic in nature, so there's no IOC containers, there's no dependency injection, there's no solid, dry, that sort of stuff. That just gets in the road of trying to deliver a message. But one of the things I think we should do as software developers is anytime you're putting code up on GitHub or on Stack Overflow, please make sure you put comments in there saying this is not production code. In production, you should do something different. This is how to solve the problem that you're looking at, but please apply it with production-like code. Because I see too many Stack Overflow solutions that just get copy-pasted in. And the guy obviously intended it not to be used like that, but if you put the comments in there, not production code, please do this in production. It at least helps. So try and picture the following example as part of a bigger solution. Now, as is customary before any live coding demo, because I've done a few of these things and things can go wrong, and if you're actually doing any large technical project, you're good following this rule as well. You have to make sure the appropriate rites are observed. I mean, we're magicians at the end of the day. As Dylan said, we do magic. So part of magic is rituals. The last code demo I gave was pretty big and pretty complicated. So I think it called for half a dozen sheep and a rooster. But I'm pretty sure today's one, we can just get away with a cute little goat. So let me just get my computer here switched over. Ooh, sound a bit like Darth Vader on this. Is that okay for everyone at the back there? Can everyone see that fine? Good. Cool. Right. So what do we have in this solution? It's good that I've got a microphone on because the last couple of times I've done some live coding without microphones at meetups and stuff, people think, you get sort of talking to the computer because that's where you're looking. So if we have a look at this solution, let's start off with the application here. So this is an application, it's got your typical main, it's very simple, it's got a UI, it takes some args, it calls something in the UI to encrypt the message. Let's go follow and see what that does. So let message looks like it calls the application. So the UI has an instance of the application, but the application references the UI. I think you can see a few problems already here. We let the message, and back here, we then call back to the UI again, and we set the deleted message by calling this here. This is real code. Like I've seen this kind of stuff in code bases before. Just crazy. Right. So I mean, you can see it's only got 3 classes. There's some acceptance tests here, which is nice. Yeah, that's all good. So let's get started. So my first goal in that is going to be, right, I want to create a deliverable for the new company, Stranger Eons, I think they were called. So my goal is just going to be make a new assembly we can give to them, make a new application we can give to them. So let me just get draw.io up. I haven't really got much room to move my mouse here. So we'll create a new diagram. Yeah, blank diagram, that'll do. Okay, just going to grab a circle. How big is that? Okay, cool. And then I'm just going to start off with create new console for Stranger Eon. Great. Okay, so that's my goal. It's going to keep me focused. Let's switch back here. We'll add a new project, console app. Right, so I normally like test-driven development, so I'm going to start this off. One of the first things I'm going to experiment with is I'm just going to bring across the acceptance test, and I'm going to change it for the requirements of Stranger Eon. So my first experiment is let's start with an acceptance test. Okay, I've got a few things broken there. I don't think it's time to roll back yet. It still hasn't been really 10 or 15 minutes. I'm not really going to use 10 or 15 minutes as my bar for rolling back because it is a pretty small solution, but we're going to imagine it's part of a bigger solution. So I need XUnit for a start. So let me just quickly go up here. Let's add a reference to XUnit to get rid of that red line. Always makes me wonder what Microsoft was thinking with this. Like, when would I ever not want to use the same version of a dependency that I've already got? And it always defaults to the latest. Has anyone found that? If you're in a rush and you don't pay attention, you always get the latest version. It's not very intentional. Okay, so we've got that problem solved now. I need the UI class. Okay, right. Let me go add a reference to that. I need that UI class. Master corrupt. Oh, look at that. I'm done. Or am I? So I've just added a reference to master corrupt, which has got the algorithm that we're not allowed to share. So that's a problem. I can't reference the UI because the UI is in the same assembly where we've got the algorithm that we're not allowed to share. So what do we do next? Well, what I do is I go to my Mikado graph and I think, okay, so before I make a new console app, it would be nice if I had the UI class in a common assembly or a UI assembly first. So I'm going to go here. I'm going to make a new node, and I'm going to say create new common assembly for the UI. Cool. I'm going to run out of space there, aren't I? Let me just shift that down. This isn't going to be a very interesting sort of graph. It's not going to be a spider web, if anyone's wanting a spider web or anything like that. It is a very simple example. So let's go to the favorite part now. Now, Visual Studio still goes a bit spastic sometimes when you change stuff on it and you switch branches and stuff. So I'm going to try and just leave everything open and just hope it works this time. So let's go do my favorite thing, which is git reset hard. Cool, gone, dead. Yeah, look. Come on, Visual Studio, it changed. No. All right, close the solution. Don't save it. Yeah, they still need to do some work there. Did it try and save anything? No, it didn't. Good. Right, let's reopen it then. Right. Just confirm we're back to a good state. I have a really good tool if anyone's into TDD and that sort of stuff. It's nCrunch. So nCrunch runs my tests for me automatically. If I change code, it picks up which code's changed and just runs the tests that have changed. So it looks like it's done a compile. I'll just do another compile just to check. Yep, we're all good. Right. So we're back to a known good now, and we can try this next experiment. Let's create a common assembly for the UI. Okay, so let's create another one. Let's create a class library this time, so we can share the UI. Class library. Call this common. Okay. Now let's move the UI in there. Cool. Great. Now we need master corrupt here is complaining because the UI is in a different assembly now. So let's just add a reference to common. Oh, look at that, it's all building. Ah, no it's not. We've still got a problem up here. The UI, you use the application. Okay, let me just add a reference to master corrupt. Is this going to work, by the way? Good. Oh, circular dependency. So, problem. We have a circular dependency. So, one of the things as software developers we love doing is, if there's a problem, what does it need? It needs another abstraction. There's nothing another abstraction can't solve, apart from giving you two new problems. In this case, though, we really do need an abstraction. The UI can't depend on the application class per se. It needs an implementation of an application class. So I think we can solve this problem by, first of all, refactoring the UI class to depend on an interface. So let's save that. Let's go back here. Let's move up here. Let's create the next node. So before I do that, what I might actually do is create an interface for application and use in UI class. That's probably going to be really teeny for you guys. I'll just keep saying what I'm doing then. So I'm going to create the interface for the application and use that in the UI class. So we go back here. Let's see if Visual Studio is smarter this time. Even though it's the best idea in the world, I still have my reservations. Oh, look at that. This time it did pick it up. What did I do differently? Right, let's do a quick build. Yes, we are back to a known good. Tests are on their way running. Yep, they're all good. Okay, back to a known good. So let's create an interface for a start. So if we look at what we're actually using here, I could use ReSharper, but then my demo would be over way too quickly. So I'm just going to type this all out. ReSharper, do my work for me. Alt, finish. Right, so we want an interface. An application. We probably want, let's see, that guy there. So we'll take him. Stick him on the interface there. Don't need to new that up now because we're going to use dependency inversion here by injecting it. Cool. Unit test is broken now. Obviously that's null. Okay, now I am going to save everyone the pain of doing that. I'm just going to go, yep, initialize that field. There we go. Great. Cool. Now things are still broken here because we've just added a constructor. So everywhere we were using the default constructor, we've probably got some build errors now. So fastest way to find those build errors I find is just to do a build. So new UI, okay. That's not going to work yet. Why is it not going to work? Need to put the interface on it. Cool, and there's the other one just there. Look, dependency injection. Look, mum, no IOC container. I do find it's always good to start a project without an IOC container, so I do agree with Dino to a certain extent there, because if you do your dependency injection manually, you really get a good sense for the hell and chaos you're creating for yourself. IOC containers make it just way too easy sometimes to come up with an object graph that is just very hard to debug and follow. Everything's green. Build looks pretty sweet. Let's just shift that to its own class. All right, let's call that a day. Let's ship it off to production. So let me just pull up my faithful source tree. So let's just stage all that. Give it a meaningful commit message. Create interface for application class using UI. All right. So we need to check that off as done now. So you can use whatever is easiest. I just end up coloring mine in green. So I click on it and go green, done, cool. So now we go back and we try and do the previous node again. So it shouldn't really cause us too much of a problem now because we've got the UI. Oh, look at that, I haven't extracted it to a separate class yet, have I? I've done the interface, but I haven't done the second part. So I could have done two nodes there, or I can keep going on that one there. What I'm going to do is I'm going to color that one back one white. And we've got the interface, and we've got it in the UI class. Now we want to create the common assembly. Sorry, I was getting ahead of myself there. So we do want to do this now. Let's go and create the common assembly. Add. So I'm doing the same thing again. Now I know, for example, Visual Studio is going to complain because when you do a git clean, it doesn't get rid of empty directories. So we've still got that one there, and we've still got that one there. Let's just get rid of those. Right, let's create our common class library again. Okay, now we're going to pick up the UI class, and we're going to dump it over there. UI class depends on iApplication now, which is something we can also shift. Cool, good. That one builds. These ones don't like it now because they need a reference to the UI library, which is fine. Great. Look at that. It worked. Tests passed. Build passes. Ship that one too. The interesting thing is that that I find people miss sometimes is that the owner of an interface is the class consuming it, not the class implementing it. And I think this sometimes, I've seen this happen in a lot of projects over the years where people only have one implementation of a class, so when they make an interface, they put the interface with the class. It's not really who owns the interface. The owner of the interface is the person who uses the interface, not who implements it. So that's why the interface for iApplication belongs in the common assembly. It's basically saying, hey, I've got a UI, you need to implement this interface so I can use the application. We can commit that now. Let's see, create new common library for UI. Color that one green. Now let's go back to our original goal, which had a lot of tangled stuff come off it. Remember when we first tried that? We had the circular reference, which we would have had to fix while we had stuff broken. We've had the tests running all the time with just little changes. So it's time to attack our main goal now. Going to create the new console app. going to start off with my acceptance test again. It's always a good way to drive stuff, which means I need to add my reference to XUnit again. You can see if you're taking off stuff that does require a bit of work, you could actually have this as a separate Mikado node just to make sure your references are there, and then when you start experimenting, you don't have to remove your project again. You can really break these things down as small as you want. Right, so we have our acceptance test. I've just been told I've got 5 minutes left, so this is probably going to end just on time, actually. Let's go to NuGet, grab our XUnit. Again, Microsoft's functionality of always choosing the latest doesn't get used. Right, cool. Now we add our reference to the common library, not to master corrupt, so we're not violating that business rule of not sharing another customer's algorithm. Cool. We need to new up an application. It's actually called program in this one, so what I'm going to do is I'm just going to give this guy the interface we need. I'll rename him to application. Great. Yes, I want that one. Cool. Let's implement our missing member. Now, the requirements for this customer was that when they pass in the text secret, they want their E's kept as E's, and they want their S's as 5s. So let's put in their requirements here. So it has to come back as that. And if we get our top secret algorithm here, very, very high-tech stuff. Good luck on the NSA cracking that. We want S's replaced with 5s because we're case sensitive. Secret. Oh, of course. Sorry. I took a little bit of a shortcut there. What we want to do here is we want to set deleted message. That guy. And I think we should be done. Done. Can ship it. I can fill out the rest of main first, but I think you can see where it goes from there. So, I can color in that last Mikado thing there, graph there. And I'm going to switch back to my presentation now so we can just finish off the last couple of slides. Okay, so I want to duplicate, extend, sorry. And then I want to put that over there. Yep. Good. So takeaways. We finished our demo. Nothing went wrong, so the goat must have been enough. The Mikado method provides you a structured way for implementing technical changes. I hope that little taste there sort of showed you that you can easily do that on a large code base. It doesn't matter what the size of the code base, you can apply that technique regardless. It is divide and conquer. You saw how when I did the first change, a lot of stuff went red. I just divided it, found something I could do first. More stuff went red, I divided that, and then I tackled those first. Just divide and conquer. Works for individuals and groups. There's only 4 steps. Set a goal, experiment, visualize, undo, and then go back and do another experiment. Set another goal, do more experiments. That's all you've got to do. And it really can unlock continuous integration and deployment for complex code changes, which gets rid of that refactoring branch that just comes back and bites everyone in the butt. There's some interesting links there. That's the book, The Mikado Method. I think it's around 25, 30 euros. It's a really good book. It should be in everyone's technical library. The last half of the book goes into code smells and refactoring techniques, so sort of overlaps a little bit with Michael Feather's book and what Dino was talking about. But the first half of it is a really good, deep introduction to the Mikado method. Just been told it's the end. So yeah, I've got a blog post on it that I wrote a number of years ago, and there's the paper that I referenced there by George Miller. So I'll leave that up so you guys can take some photos. I did have a question slide, but I'll go back to that one so you guys can take some photos. So any questions?
And what about, I don't know, short-term projects that should be done in less terms, like, I don't know, 2 weeks, 3 weeks, and other? Could it work, or there are another methods to finish?
No, I've used the Mikado method on 1 hour changes, so it doesn't really matter how long the project is. You can use it for short-term and for long-term. The one thing that comes back to me is that every time I think that I'm tackling something that looks like it's going to be small, and I go, I'm not going to go through the effort, because it's not much effort of opening up a web browser and going to MindMap and starting a Mikado graph. Every time I go through, I'm not going to go through the effort, I'm just going to make the change. It's always bitten me in the behind, and it ends up being more complicated. So almost all the time now, regardless of whether I'm doing a 30-minute bug fix or a 5-day, 2-week, really large feature, I always have a Mikado graph for it.
So you just take, I don't know, an hour to analyze the situation, and then...
So this is a key point they mentioned in the book, and because my slide, I don't really have enough time to fit the whole thing in there, is desk checking is probably not a good approach. This is why experimenting is a good approach, but you can only experiment if you've got test coverage or if you've got a static compiler. I mean, for guys using dynamic languages like Ruby, Python, JavaScript, yeah, good luck. You have to have really good test coverage. But if you're lucky and you've got a static language, you can lean a lot on the compiler to find when you've broken stuff. It's still not going to help you when you've changed behavior. That's why you need the test coverage.
Thank you.
Yeah. Cool.
Yeah. Thanks for the presentation. And my question is, when we're using this flow, when we should create PR? When we achieve the final goal, or when we're achieving each of the points? So where's like the compromise between the size of the PR and the amount of PRs, because otherwise you are on the risk to being stuck on these PRs, and then you will spend more time even than like doing all of the stuff.
I mean, the question we have to ask is, what's the alternative first? So if you're not using the Mikado method, the only other alternative is either large PRs with a whole bunch of crap in them, or I don't know what the alternative is actually, but that's generally what I've seen happens. With the Mikado method, you can choose what makes sense for your team. I'm normally a pretty big proponent of small pull requests, and then once the feature's finished, we go through an architectural review of a feature, because if you don't do that, you're never seeing the whole picture. If you're only seeing little pull requests, you're not actually seeing where the design is going, which is kind of bad as well. But the code getting into production quickly has got a very high value. Even though it doesn't change anything, that code being in the main line and being in production has importance because it's running. So I generally favor smaller PRs, every hour. Here, I finished a chunk of work, doesn't do anything, but if you look at my Mikado graph, this is where I'm going, this is all the stuff I've found out, and these are the things I'm solving here. My next pull request is probably going to be this part, maybe that part, and then your 5th or 6th or nth pull request will be the goal in the middle. So it's up to how your team works, though. I mean, if I've got someone that gives me pull requests that are like 4 days worth of work, then I'm going to give them a big pull request back.
You told that we do not need additional branches. We can put all our changes just in develop branch because we move forward with small portions. But when you start applying this method, you do not have the full graph. You add steps dynamically.
Yep.
So what if at some point you understand that the graph is too large, you are not move forward this way, you have to roll back everything, but everything is already in your developed branch.
Yeah. Again, it's one of those things that depends, hashtag it depends. There's value getting those changes into other developers because they can use them. But then if they're wrong, you've kind of got to question what the changes were you were doing anyway, because a lot of the changes you do as part of the Mikado method are in general solving code smells in your code base anyway. So you're going to want to keep those. There's lots of things that can happen. You can pick up something that looks small and go, oh, that's a small goal, I'm going to start there. And then you can have it just explode and it just gets like, whoa, this is like a month's worth of work. At that point in time, you've probably got a few commits you might have put in there. They might have fixed a few problems with the existing code base. They're most likely going to be keepers. If it was a new class you added, you can just go delete that class if no one else is using it yet. But at any point in time, you can also make another Mikado graph of one of those goals. So you can have a goal, then find some prerequisites, and then one of the prerequisites is big. It's like, okay, what I'm going to do is I'm going to stop there, I'm going to draw a special symbol on it, and that's going to become a goal in another Mikado graph, and I'm going to give that to someone else to work in parallel, if that's the way your team works. And then I'm going to track that change on there, and when I finish it, I'm going to come back to my original one, and then I can continue on. That does happen. Yep. Sometimes it's like, this is looking really nice, and then you get to the edge, and it's like, another big explosion. But the alternative is, if I wasn't using the Mikado method, what would my code look like then? It would be a very big explosion.
Thanks.
All right, thank you very much, but I'm afraid that our time has run out. However, you may join Nathan at the Speaker's Corner in 15 minutes. Let's give a round of applause for our speaker, Nathan, here.
Thanks, guys.